So my research was on metasemitism and infiltration of the actinolite talc actinides during subduction on Santa Catalina Island, California, and isocon analysis. So episodic tremor and slip is a process that occurs in subduction zones and is potentially related to large-scale earthquakes. And it may also lead to improved estimates of where and when the next great earthquake is likely to occur. However, ETS still remains poorly understood, particularly the potential role that processes such as metamorphism and metasemitism, which is chemical alteration of a rock caused by hydrothermal fluids, as well as mechanical mixing play in producing them. So by determining the major and trace element changes, it betters our understanding of the geochemical evolution of subduction zone interfaces and how this produces weak minerals that may host ETS. So the epidot and fibrillate unit on Santa Catalina Island is a paleo-subduction terrain containing exhumed hybrid rocks from the subduction interface. We measured major and trace element concentrations of 8 samples from 3 different lithologies. These were actinolite, talc actinolite schist, and chloride actinolite schist. And these are all from typical pressure temperature conditions for ETS in modern subduction zones. So in determining the major and trace element changes, firstly, we used field evidence and spider diagrams to group samples as either metasedimentary derived or meta-ultramafic derived. So the green lines of the diagram represents the meta-ultramafic group and had higher concentrations in chromium, cobalt, and nickel. And this is typical chemical signatures of ultramafic rocks. So the metasedimentary group is in blue and was enriched in the rare earth elements and is also consistent with what we expect from sedimentary rocks. The yellow line represents sample B1 and it showed both metasedimentary and meta-ultramafic behavior, and therefore we used it in both groups. So we used isocon analysis to solve for the change in mass and concentration for each sample. The isocon presents a straight line, which is defined by immobile elements, and then gains and losses of other elements can be calculated relative to this line. So components above the line have been gained, while components below the line have been lost, and components on the isocon have stayed relatively immobile. So we found that the total mass increase of all samples ranged from 47 to 480%, and only a talc actinolite sample had a total mass decrease of around 25%. Strontium was gained by the meta-ultramafic group and lost by the metasedimentary group, which indicates that there was some local exchange thereof. The metasedimentary samples also saw significant increases in calcium, magnesium, and manganese, whilst the meta-ultramafic group had increases in silica, calcium, sodium, magnesium, and titanium. Further, decreases in elements indicate that there was leaching by fluids in the reaction zone. A possible fluid source that could explain these increases is fluids from the underlying metapillar basalts, and evidence in the field, such as epidot veins, could be the direct evidence of fluids bearing the right chemical compositions to produce these chemical changes. So these results suggest that local exchange, external fluid infiltration, and leaching by fluids are all required to cause these chemical changes and together produce weak rocks that may host slow slip events in the EA unit on Santa Catalina Island. And then there are my funding and land acknowledgements. Thank you.
That was great. Thank you, Courtney. Okay, floor is open for questions. I have, oh, Lon has a question. Go ahead, Lon.
Really nice job, Courtney. So what do you feel are the next steps to take this into the future?
Okay, great question. So firstly, I would say isotopic analysis of both the samples and then also the possible fluid sources to confirm if those are the fluid sources, and also to look for evidence in these rocks for slow slip events, evidence in the rocks of slow slip events.
Okay, Enrique.
Nice job. Just curious, so I guess to better my understanding, I don't want to say the precipitation of these minerals, but the, I guess, formation of these minerals seems to be somewhat aligned within certain directions, these veins. And do you think that that has anything, or do you think that alignment or orientation relative to the stress field of, you know, said subduction zone that was active in the past, do you think that has anything to do with I don't know, preferential activation, or could that play a role in preferential activation of slip events?
That is a great question. Unfortunately, I feel like that's a little bit out of the scope of the research I did, so I couldn't confidently give you a good answer for that.
Fair enough.
Sorry.
That's fine. Yeah, stress orientations are just something I'm interested, so maybe that's why I asked.
Okay, if you have any further questions for Courtney, you can put them in the chat, or again, I can share her email with you so you can continue this conversation later.